Okay, so we can do the next test, which is testing whether the average of test score is equal to 653, which is actually uh, the actual mean in the data set. So our null hypothesis is the mean is equal to 653, and based on the p-value of the alternative two-sided test, we find that there is a high probability. When I say high, it's higher than significance levels, the three significance levels, 1%, 5%, and 10%. So this is 21.42%. So it's a high probability. So there is a high probability that this null is true. So we fail to reject the null and conclude that the mean is equal to 653. And if you look at the one-sided test towards the right or the left, they confirm the same answer, which is failing to reject the null. There is a high probability, 89.29% that the null is true, and this 10.71% that the null is true, or is that test score is equal to 653. We can also try to test the two variables for test score, high and low. Okay, so let me rerun the or generate them again because I started all over from the previous video. So now we have them. So let's try to test. So based on the first one, whether the mean of test score low is equal to 0. So what we have here is there is zero probability that it's equal to 0. So we reject the null and confirm and accept the alternative that it is not equal to 0 or it's statistically significant. This one is also rejecting the null and accepting that the mean is greater than 0. And this one is failing to reject the null and concluding that failing to reject the null and concluding that the mean is equal to 0, which is better than saying it's negative. So if you see that the mean is already positive, you can actually either go with this two-sided test or just the right hand or right side test. Okay, and both of them are saying the same conclusion that the mean is not equal to 0, it's positive. The same thing here. So for the test score high, we see that the number here is 649, which is positive. So if I go with a two-sided test, there is zero probability that the null is true. So we reject the null and conclude that the mean is not equal to 0, statistically significant. And based on this one, it is positive. Okay. The next thing that we can do is I want you also to read all the green lines here because I'm like adding more information for you. So if I want to test whether the test score in a small size class is the same as the average test score in a large class size. So to do that, we need to compare the means, right? So we need to compare the means between the average test score of a low or a small class size and the test score for a high class size. We can use the option unequal. So unequal here is used when the two variances of the two populations are not the same. We use unpaired when we assume that they are independent, so they are or their variances are independent. So what we can do here is we can run the test, and what we see here is the difference is 7.37, so it's positive, right? So in other words, which makes sense that small class sizes have a larger score than on average than large class sizes, okay? Or class sizes which are small, the average test score is higher than the classes with larger number of students. So the mean is, or the difference in means is positive. So you can either go with a two-sided test or the positive sided test. And this one is telling me that there is a small probability that the difference is equal to 0. So we reject the null and accept the alternative that the difference is not equal to 0 and statistically you can call it statistically significant. And to be more specific, if you want to test whether it's statistically significantly positive, then you do a one-sided test. And again, this p-value here, there is zero probability that the difference is equal to 0. So we reject the null and accept the alternative that the difference is positive. Okay, so the difference, which is approximately 37, is statistically significant, statistically meaningful. Okay, and if you want to learn more about the t-test, I want you to follow this link here. It's from UCLA, so you can read like more details, more examples. You can see more examples here. And as I told you before, when you had the help command before any syntax, you can also get more details about the command, you get examples and so on. So if you want to know more about the t-test, you can type help, and this would show you like different or detailed information about the command with different options that you can add, the examples that you can use. Okay, so you have here if you type the auto dataset, then you can check this command whether the t-test is equal to miles per gallon is equal to 20. So this is the one sample t-test, or you can do the two sample t-test or the paired, right? So you can like have different things that you can try. So always typing the command help can offer you with so many details about the different commands that we are using in Stata. Okay, so and then you can add log close toward the end to close your log file. Okay, I would always suggest, especially the first couple of weeks of the semester, that when you write your do file, you can run it line by line as we did. Okay, and towards the end of the semester, later in the semester, when you're more experienced with using Stata, you can just type it all and then hit run just once, and then would be run in like less than a minute, and you get all the output. Okay, so if you have any questions, please email me or write on the discussion form. Thank you.